Ever wondered how industries monitor and control their processes in real time? Well, this is where SCADA systems, short for supervisory control and data acquisition, come into play. SCADA is a control system architecture that's used across various sectors, be it manufacturing, energy, water treatment, transportation, or telecommunications. At its core, a SCADA system is made up of several key components. First, we have supervisory control, which enables operators to monitor and control processes remotely. Then there's data acquisition, which involves collecting data from sensors and devices in the field. Control devices, another key component, allow SCADA systems to send commands to equipment like valves, pumps, and motors. We also have the human-machine interface, or HMI, which provides a visual representation of the processes, and the communication infrastructure, which enables data transmission. Lastly, data storage and analysis helps in identifying trends and optimizing processes. Now let's explore each of these components in more detail. Imagine being able to control an entire industrial process from a central location. That's the power of supervisory control. This key component of a supervisory control and data acquisition, or SCADA system, is like the brains of the operation. It enables operators to keep tabs on complex processes in real time, all from a single spot. Think of it like a conductor leading an orchestra. The conductor doesn't play an instrument, but they oversee everything, guiding the musicians to create a harmonious performance. Similarly, supervisory control doesn't directly engage with the processes. Instead, it collects real-time data, presents it in an understandable format, and allows operators to make necessary adjustments to keep everything running smoothly. From manufacturing to water treatment, energy to transportation, this technology enables remote monitoring and control of industrial processes. It's like having a bird's eye view of the entire operation. But how does the system acquire the necessary data? Let's find out. Data acquisition is the heart of a SCADA system, pumping vital information throughout. Picture this. Scattered across the industrial landscape are sensors, meters, and other devices, each gathering data from its specific corner of the operation. These are the eyes and ears of the SCADA system, picking up on everything from temperature shifts to pressure changes, and sending this information back to the central system. But what good is all this data if we can't put it to use? That's where control devices come into play. Think valves, pumps, motors, and other equipment, which are the hands of the SCADA system. These devices receive commands from the central system, allowing for remote control and automation of industrial processes. With all this data and control, how does the operator interact with the system? Enter the human-machine interface. The human-machine interface, or HMI, is the face of a SCADA system. It's through this graphical interface that operators interact with the system, like a conductor leading an orchestra. The HMI provides a visual representation of the processes, offering a window into the complex world of industrial operations. Imagine you're in a control room looking at a screen. On this screen, there's a detailed layout of a factory floor, a power plant, or even a water treatment facility. Each pump, valve, and sensor is represented by an icon, and each icon provides real-time data about its status. That's the power of the HMI. It takes the vast amount of data collected by the SCADA system and presents it in a way that's intuitive and easy to understand. But the HMI isn't just about monitoring, it also allows for control. With a few clicks, operators can adjust settings, control equipment, and respond to issues in real time. It's like having a direct line to every piece of machinery in the facility, all from a single location. But how does all this data get from the field devices to the HMI? That's where the communication infrastructure comes into play. SCADA systems rely on communication networks to transmit data between the central system and the field devices. This can include both wired and wireless technologies, from traditional Ethernet cables to advanced cellular networks. These communication networks are like the veins and arteries of the SCADA system, pumping data back and forth between the heart, the central system, and the limbs, the field devices. They ensure that every piece of data, no matter how small, finds its way to where it needs to go. But communication isn't just about data transmission. It's also about security. In an age of increasing cyber threats, ensuring the secure transmission of data is more important than ever. This is why modern SCADA systems often incorporate advanced security measures. From encryption to intrusion detection systems. All this data needs to be stored somewhere, right? That's where data storage and analysis come into play. Data storage and analysis are the brain of a SCADA system, making sense of all the information. This is where all the data collected from various sensors, meters, and devices gets stored for historical records. It's like a vast library of industrial processes containing a wealth of information that can be analyzed to identify trends, optimize processes, and improve overall system efficiency. Think of it like this. Imagine you're trying to improve the performance of a professional sports team. You wouldn't just watch one game and make your decision. No, you'd want to look at their performance over a season or even several seasons. You'd analyze their strengths and weaknesses, identify patterns and trends, and use this information to guide your strategy. That's exactly what the SCADA system does with its data storage and analysis. But it's not just about looking at the past. This data also plays a crucial role in real-time decision-making. By comparing current data with historical trends, the SCADA system can predict potential issues before they occur, helping to prevent downtime and improve operational efficiency. It's like having a crystal ball that can see into the future of your industrial processes. As we wrap up, let's take a moment to appreciate the sheer importance of SCADA systems in our industries. From manufacturing to energy, water treatment to transportation, these systems are the silent heroes, working tirelessly behind the scenes to monitor and control processes, ensuring everything runs smoothly and efficiently. But as with any hero, they need protection. In the case of SCADA systems, it's protection from potential cyber threats. As these systems often control critical infrastructure, implementing robust security measures is not just important, it's essential. So there you have it. The SCADA system, a marvel of modern engineering, collecting data, controlling processes, analyzing information, and helping to keep our industries running like well-oiled machines. SCADA systems are the silent heroes of our industries, working behind the scenes to ensure everything runs smoothly and efficiently.